and everything. So our topic is going to be on, agentic AI. So the whole process is mostly just introduction, then presentation, and then question and answers right after the presentation. But because of time, we'll do it after both yourself and Mr. Warren has presented. Okay, Warren, are you able to share your screen?
Okay, yes. I was just trying to confirm if you've seen me. Okay. So please confirm you've seen my screen. Confirm you've seen my screen, sir.
Okay, not yet. It's still loading.
Oh, all right. Okay.
Okay, yes, we can see your screen now.
Oh, okay. That's fine. So confirm you can see it, sir.
We can see your screen.
Oh, okay. I just want to put it on. It's still putting. I'm just trying to put it on slideshow. So please just bear with me. It's still coming up. It's trying to come up so that I'll put it on slide show. I don't know, for some reasons it's taking time.
Okay, Warren, are you there? Seems like
Yeah. Yes, I'm here, but it's telling me, I don't know.
okay, seems like you're having some difficulties.
Can I go on like this?
You're having some difficulties there. Maybe we can set this up
I don't know why it's not
later. Let's have Mr.
not
Abidemi.
showing, it's not giving me slide mode.
Okay, are you hearing me? So I say, okay, while you try and sort this out, maybe after let Mr. Abidemi go on with his own. Let Mr. Abidemi go
What
on
did you
with his
say?
let Mr. Abidemi go on with his presentation, his own slides, and then maybe you will do after him. But it seems like you're having difficulties here. Did you get that?
Seems having network issue.
Yes, it's having network issue. Let me send him a message.
I didn't say. Okay, I think it's coming up now. Okay. Hello, sir, can you hear me?
Yes, we can hear you.
Okay, so I think
Okay, I was saying since you're
it's
having
coming up
network
now.
issue,
So
let's Mr. Harvey, let me go on with his start first.
okay. By then, by the time I finish it, I think my
Okay, that's fine. So you can just unshare your
own
screen
would have come up.
if it's coming up now.
Oh, okay. Eh? Say what, sir? Okay, let me stop sharing the screen so that let me stop sharing the screen.
All right. Let me see if I can. Okay.
I can proceed, right?
Yeah, Mr. Abdul, you can proceed.
Okay. Sorry, can everyone see my screen now?
Yes, we can see your screen.
Okay. So, good afternoon, everyone. My name is Abidemi. I'm a artificial intelligence and a data science engineer. I'm happy to be here to present this topic to you guys. Agentic AI. I think is what everybody have been know about. Everybody have been coming about agent AI. But we want to just go deep into it and know what agent AI is, know the application behind it. So I think everybody's trying to differentiate between agentic AI with traditional AI. Basically, agentic AI is just like a system where a language models and their tools, the language model are tools that allow the workflow to exit. The different kind of workflow depends on what you want to use this for. And agentic AI is just like let's put it into this scenario like a self-driving car. The way they authorize it, they automate is they integrate agentic AI into it. So basically the another difference between is how agent AI the traditional AI is just like let me say they use how machine learning integration work. What agentic AI is, it can do anything by itself independently with a minimum human interventions or human input. This is my introduction regarding agentic AI. Agentic AI integrates large language models, machine learning, enterprises, automation to create autonomous AI agents capable of decision making, a goal setting, a problem solving, adapting to unstructured environments unlike rural-based area. Unlike rural-based AI is basically, we are talking about this traditional AI. That's the rural-based AI. How agentic AI work independently with assistance, with little assistance with the human interventions. There are different aspects of it, and also before you understand about agentic AI, you have to understand about the workflow. There's a workflow behind it. First of all, we talking about the workflow. A workflow is just like a system also where large language models and some tool they orchestrate some action. And there's a different workflow, depends of how we are going to eat. I don't want to go deep. I don't want to just give a background about the workflow, basically. The workflow, first of all, you have to understand what, let me say, a little understanding about the plant engineering, the way you want to plant your work, the plant, let me say plant chaining, let me not go into that word, a plant chaining, how you are going to orchestrate your work. After the plant chaining, you have also know about a router. A router is just a brain box that allow agentic to work. Your router may be agentic. For instance, let me say what router can actually relate to is, let me say OpenAI. Let me say OpenAI, how it work, because you are connecting the router basically just like a brain model, a brain box that allow different kind of the agent to connect to it. And before you also ask, after you understand outside, you also about the parallelization. Parallelization is a sequence behind how you, connect your model Also, after parallelization, you also have orchestrated worker. We understand about orchestrated worker is also a separation behind how the agentic AI also work. After orchestration worker, we understand elevator optimizer. Elevator optimizer is just like the endpoint behind agentic AI, how the agentic AI, the output work. Like agentic AI work based on the initial phase you want to know about it is basically first the user inputs, user request. After you read that request, whatever you connect to it, which is your agent. Agent can come from the language model. Let me use example OpenAI because I deal with OpenAI very well. And from there, you connect a language model to it. It may be 1, 2, 3, depends on how you are going to do it. We have a different parallelization. That's how you are going to integrate agent AI. The core aspect of it is to understand the workflow. Without understanding the workflow, it will be extremely hard for you to know how agentic AI works. Don't forget in the back of your head that agentic AI works based on the workflow. First, the prompt chaining, after prompt chaining, routing, after routing, parallelization. After parallelization, after parallelization, you will know about the orchestrator worker. After orchestrator worker, you understand about the evaluator optimizer. So evolution of agent AI. These are the evolution of agent AI. First of all, you have to understand early models, which is what a traditional model actually was. And from then, you understand all machine learning era. AI begin adapting and learning patterns. It can come from a supervised learning supervised learning, unsupervised learning, semi-supervised learning, or reinforcement learning. You have to understand the evolution behind it. You can't just jump into the agentic AI. You have to understand the prerequisite knowledge about how those things work. From then, you understand language model, how that will enhance the contextual understanding that train a different large language, that train a different large data set. And then since I've discussed about how agentic AI work, understanding, goal setting, execution, learning. First of all, you have to understand AI processing data using large language model machine learning. That was thing you need to understand. From then, you go depth into the goal setting. What do you want to do? What are you going to achieve? Executions. How do you want to execute the task? That is where our human efforts require. You don't need to ask. You don't need more effort. You just need to understand the domain behind it. Human effort and automate a task with a minimal human input. Another thing you're going to understand, learning continuously, improve through the interactions. You have to interact with some set of people. From then, that will where a deployment and the maintenance coming. I couldn't implement those things to it. Sorry. From then, we go into the benefit of agentic AI. Agentic AI improve efficiencies, scalability, adaptability, and collaboration, and cost of reduction and continuous learning. From the efficiency, reduce the minimal work and they automate a complex task, improve the productivities. An AI then can adapt to a business growth and or evolving demand. Adaptabilities respond dynamically to real-time changes and unstructured environments. Collaboration, work around the human, enhance decision-making and workflow. Cost reduction, lower operational expenses by automate repetitive and the resources intense process. Continuous learning, improve performance over time through the data-driven insights and machine learning. I think I've explained a little bit about this agent AI and agentic AI. Agent AI works based on the autonomous, while agentic AI works based on creativities. A rigor-oriented, output-oriented, a real-time environment, a content-based environment, all have a background without API tools and utilize tools, it cannot work, it cannot implement, it cannot make use of the workflow of agentic AI. You have to understand the workflow. For genetic AI, you don't need APIs, application programming interface, container adaptation from real time, autonomous system, content creations, while independent decision making, decision based on the input patterns. That is where machine learning and those things and then computer visions. Okay. Application of agentic AI. In autonomous vehicle is a work based on in autonomous vehicle, healthcare, finance, and customer service. This is on user input, and then whatever you input on the car self-driving car, you advance the driving assistance system. It also help electronic health record, also help in the hearing, in the record of a hearing faster, also integrate the healthcare chatbots in the customers, in the finance. You can host for the customer relationship management system. For the customer service, also have a sentiment analysis chatbot to know the feedback from the patient, from your clients, either positive, negative, neutral. Use case of agentic AI and automations. And it's part of the use case, and we have the automated data analysis. You can use agentic AI to automate. You can use agentic AI to automate your data analysis to interpret a trend and a real time, and also supply chain optimization, analytics, and predict analytics, improve logistics. For the IT and the security, AI driving cybersecurity and the trend detentions. For instance, it can also help from the spam detention, a flood detentions, or self-healing system that I discovered this early, that's in the healthcare industry, I resolve technical issue autonomously. The risk and the challenge of agent AI, bias and a fairness issue, security and loss of human control. The challenge that everybody feels in agent AI is basically ethical concern, regulatory and corporate issues, also accountabilities and then transparencies. For the implementations, we have to understand the ethical AI development. We have to ensure the transparencies and fairness in the decision making while implementing agent AI into our ecosystem. Also understand the robotic securities measure, prevent unauthorized access and cyber threat, continuous learning, enable AI to adapt and improve with a new data, human insight, maintain control to align AI decision with a business value. I think I discussed this about how it works. This is the workflow. This is our agent. This is our user request. This is our brain boss, which is our AI agents. This is our large language models. This is where the perception come in, and from the perception, you can come with the multi-modal function, a camera, text, audio, and sensors. From our brain boss, it comes directly into recognitions, a memory and knowledge base. For the actions, is executed. The last phase is our decision making. Prior decision making is a maintenance control with efficient deployment. We have agentic AI frameworks. As again, there are a lot of framework, but there's only I bring the relevant one out. We have a LangChain. LangChain is just like an open source that allow to allow the automations of agent AI that was powered by the large language models. This AutoGen was powered by the Microsoft, I think 2022, yeah. Crew AI is a powerful agent AI framework and the open source, and the Llama Index. Llama Index is actually a very good open source as well that we use. You can use this in the times of data. You can use it to train your data as well. Big data, you want to work with the due data, I recommend the Llama Index. Also, we have NAN. What people I couldn't like it on. Where NAN is very good. If you don't want to code, you don't want to code, you can use no code open source, long code framework, which is your NAN. We also have a make.com. There's a lot of open source, depends on what you want to use. I got here with me. The future of agent AI, and the future of agent AI involves autonomous decision making and human collaboration and enhanced AI securities. They are enhanced AI securities. Once the future behind autonomous AI agents, we have AI and human collaboration and next-generation AI securities. My conclusions are I documented that agent AI is revolutionizing automations beyond simple process. Business more adapt as AI shape the future of work. Ethical AI development is essential for responsible use, and AI will continue evolving, driving innovation and transformation. But this one came into my mind. Traditional AI is like a tool you have to use. While agent AI is like a teammate that get things done. The real shift is not just intelligence, it's an initiative. When AI start planning, adapting, and collaborating on its own, it's not just scaling technology, you are scaling decision making. Thank you for listening. Thank you, guys. That is the end of the presentations.
Okay. Okay, thank you very much. This was a very insightful on agentic AI. Is This is very insightful for the agentic AI. Will be some question for it, but before that, Umoren, are you now ready? Are you ready for yours?
It's like you have to unmute me from your side, please.
Okay, let me do that. Okay, so you can go on with yours, Umoren. So after Umoren, we will now do a question and answer session because I do have some insightful questions for this presentation I've seen here. All right, Umoren, can you share your screen now?
Yeah, I want to share it now, sir. I'm sharing my screen, so please, once you see it, just let me know, sir, please, if that's okay.
All right.
Confirm you can see my screen, sir.
Still loading.
Okay, still loading.
Okay, please confirm now you can see my screen.
It's still loading. All right, we can see your screen now.
Okay, you can see it now. Okay, perfect. Okay, so once again, I want to apologize for the interruption, breaking transmission, as newscasters will say it. By way of introduction, my name is Nso Moren. I am a data scientist, and I am one of the presenters today. I will be speaking on Agentic AI, the next evolution of artificial intelligence. The icon you're seeing here, the icon you're seeing there is just an image. It is an abstract illustration of artificial intelligence agents, okay, and is represented as glowing nodes, okay, that is connected to a network. Now, before I continue, I would like to say that we will explore agentic AI, the next major leap beyond generative artificial intelligence. We would examine how AI is moving from reactive system to autonomous and goal-driven agents. I will cover architecture, tools, risk, and real-world applications. Okay. The typical example I will just mention here is futuristic digital workspace with artificial intelligence agents collaborating. Okay. Okay. So what is this agentic AI? Now, before we go into that, I want us to look at this flow chart that is showing chatbot versus agentic AI. Traditional chatbot, of course, user in this case will prompt and wait for a single response. Okay. Now, that is reactive. That is reactive. So traditional chatbot always wait for input from the user. And in this case, of course, there's no memory, no goals at all. So you just have to wait when you're inputting any data in traditional chatbot. But that is not the case for agentic AI. Agentic AI, in this case, a goal is assigned to an agent, which is artificial intelligence, and it will take this task and break it into subtasks. Of course, plan, act, reflect, and repeat. And that is proactive, goal-driven, multi-steps, and autonomous, independent. So we are moving from reactive to proactive systems. We are moving beyond chatbots as it is right now. And we can see from what I've shown you through this flowchart that agentic AI is a goal-driven, not prompt-driven, meaning it takes initiative. It is initiative-taking behavior that it has that makes it different from normal or traditional chatbots. It plans and executes complex tasks. That makes it multi-step decision-making. Another thing is that agentic AI it operates independently. It's autonomous. Of course, it is a digital employee. It doesn't need assistant at all. It doesn't need assistant whatsoever. It operates on its own. So that is agentic AI. That is what we can say about agentic AI. So the typical example for this agentic AI is actually, I would say a travel planning agent, okay, that books flights, hotels, and then creates itineraries proactively. That is an example of agentic AI. Now, defining agentness. Defining agentness. The 4 dimensions of agentness that we are going to look at. And the icon you're seeing here is basically representing autonomy, planning, tool usage, adaptability. So the autonomy. Agentic AI works without constant prompts. That I have talked about. It works without constant prompts, meaning autonomy is the system that can operate independently. Okay. Then planning capabilities allows it to decompose complex tasks. So it breaks complex tasks into steps before it executes. That is the advantage of agentic AI. Tool usage enables interaction with APIs, okay, databases, external systems. Adaptability, of course, adaptability ensures improvement through memory and through memory, okay? And what that means is that it learns from past outcomes. It learns from past outcomes. So that is advantages of agentic AI over traditional chatbots. Now we are going to look at the 4 core component architecture overview. Now we have the agents here, the agentic AI here, the LLM core, large language model core, all right? And we have perception here. We have perception, we have reasoning, we have action and memory reflection, okay? And what it does is that the agentic systems actually rely on these 4 foundational pillars, okay? These components allow them to sense, think, act, and improve. And together, they mimic elements of human problem solving. The typical example I will give here is a customer that supports agents, that perceives queries, okay, reasons about solutions, acts via ticketing, and learns from feedback. That is the typical example that I can give here. Perception. Now, this you're seeing here, this is an illustration of sensor, okay, APIs and databases feeding into an AI brain, okay? So what that means is that perception is how this AI agents understands the environment, okay? How do they understand the environment? So when they understand the environment, they use APIs to fetch structured data, okay? RAC will now connect them to vector databases for contextual accuracy. In physical systems, of course, sensors can feed real-time data, okay? So this is the perception, this is connected to this agent. So it will now, it will now understand the environment. The AI will now understand this environment and then use this API to gather data, okay? Now the RAC then will now connect them to vector databases, okay, for conceptual accuracy. Now, to cap this, so data gathering via APIs, meaning it's gathered this information through APIs, that is the agentic AI gathered this information or data, whatever, it gathers it through API, that is structured internal data. Retrieval augmented generation means this is connected, this now connects them to vector databases for conceptual accuracy. And these sensors, of course, fit real-time data for physical systems. Reasoning, task decomposition. So what this means is, this is agentic AI that is being assigned goal, okay? Now, when he gets this goal, he first of all will now, take initiative. It will not just answer. It's not just question and answer. No, it will just break this goal into subtasks, giving this this LLM, which is the large language models planning and strategy formation. So it will now give to the AI, agentic AI here. Then what he would do would be to break it into substacks. And one would be to gather the data. That is the step one. The step two would be to analyze it. And then, it will now execute, and it will execute the plan. And that's what it's going to do. So agentic AI does not just take input and just question and answer. No, it breaks it down into subtasks and then proceed from there. So large language models will enable it reasoning. Agents break compressed goals into manageable subtasks. They generate execution plans before acting. They don't just answer questions. They just break it into subtasks before acting. This is what differentiates them from simple automation scripts. The example I will give here is, let us look at artificial intelligence project manager breaking down a product, launch into task. Okay, that is a good example. So, and once this happened, this is the process. This is the what would I say, flow chart of the task decomposition. Like I said, AI, artificial intelligent agents, will just have to, break them down. And this is not the case for traditional chatbot. This is not the case for normal, AI. Okay. Action interacting with real systems. Actions interacting with real systems. Okay. Now, this is, I would say, it is an icon set, okay, showing API calls, SQL queries, and workflow automation. Okay. Now, what it does here is that action is where agents, of course, will interact with real systems. And they can send APIs requests, okay, updates databases, and also trigger workflows. This make them, of course, operational and not conversational, okay? So the two calling here will send or receive real external data. And then SQL databases execution, what happens here is that it will send the query and update records directly, okay? And the workflow, of course, automation is to trigger multi-systems operations. Now, want to talk on this memory reflection. So this is memory and reflection loop. And what you're seeing here is a brain-like structure, of course, with a memory nodes, okay? So memory, of course, will allow agents to retain context across sections, okay? So a reflection here will help them to evaluate performance. And then over time, this will improve decision quality and efficiency, okay? So long-time context storage retains knowledge across sections. Of course, I'm just recapping. And learning from past outcomes would, of course, evaluate what worked or what failed. And improving decision quality over time will mean continuous improvement. Okay, so this is a multi-agent systems. And what you're seeing here is like a team of AI vendors collaborating. Okay, this is multi-agent collaboration, and this is orchestrator. This is the AI, of course, will have to assign tasks to agents. So it will assign tasks to this coder agent, and this coder agent task is his own main job or responsibility is just to write codes. And then review agent is his own job here is to, review, would I say, quality assurance and debugging. And docs agent is for documentation. Deploy agent is to release builds. So instead of one agent doing everything, multiple agents collaborate. For example, one agent writes code while another review it. This mimic team-based human workflows. So Flowworks, like Microsoft's AutoGen, enable such collaboration. So share good, deliver working software. So agents collaborate on shared goals. For example, coder and reviewer and deploy agents and frameworks, auto agents, and crew AI. Okay, so shift from generative AI to agentic AI. So what you're seeing here is nothing but split screen, okay? Comparison. So split screen comparison between generative AI versus agentic AI, okay? So generative AI, like OpenAI models, responds when prompted. Like I mentioned last time, user will prompt and then wait for single response. And I also said that is reactive. So traditional chatbot, of course, is something that will have to wait for input before it to respond. And that simply shows no memory, no goals at all. So that is what you see there. But then agentic AI, of course, it acts, it takes the goal that is assigned to it, and then would independently act once this goal is now assigned to it, and will now say, okay, this is the plan is we have to plan, we have to act, reflect, and repeat, which is proactive, goal-driven, multi-steps, autonomous. So reactive response to prompts, that is traditional chatbot. And proactive is like, I would say it takes initiative. So it is initiative taking behavior that it has. So that is proactive, takes initiative. Then text generation, that is produces content. And text generation, it will fall into generative AI, okay? It will just produce content, that's all. But in the case of agentic AI, what it does is it has to complete the task. Once tasks are assigned to it, it will complete the task. So goal achievement is what agentic AI is doing for us. So the typical example I would give here actually is generative AI writes an essay, okay? That's all, because that is what it can do. But agentic AI, of course, would make researches, would draft, would edit, and submit it. So you see, it breaks it down. It does not really give a question and answer kind of response, unlike a traditional chatbot. Okay, so this is to access an enterprise to orchestration. So what we have here is, basically is enterprise systems, icons connected to an artificial intelligence hub. Okay, this is artificial intelligence and Midway. So this artificial intelligence, you have these tools here. Artificial intelligence is connected to these enterprise tools. These are the tools here. So it's connected to them. For example, it can update leads in Salesforce. Okay. It can create tickets in Jira. Okay. It may even query SQL databases for real-time insights. This makes it enterprise ready. Okay. It makes it enterprise ready, obviously. So, basically, when you have artificial, you have artificial intelligence agent here, it does not understand what these tools will be talking to. So that is why you have this middleware, who will now interpret whatever this message they will send to the AI. It will now interpret to them. Just look at someone traveling to Paris, for example. We are an English-speaking country, and we travel to Paris. And when we get to Paris, they speak French. So having someone who is a translator that will interpret what a French person is speaking and what we will be talking, okay, to the person, with the person there standing there as a translator, in this case, is a middleware. So this middleware tries to interpret whatever these tools, these enterprise tools will be sending to AI. And then AI will now use that to work properly. Okay, so middleware between AI and enterprise connects their separate systems. And this CRM, ERP, DevOps integration. CRM means customer relationship manager. ERP means enterprise resource planning, and of course, development and operations integration. So this is like a software that you have. This is a software you have, and that is being integrated into AI, or AI is integrated into them. So they work end to end. That is no manual hands-offs required. Okay. So the typical example here, of course, is artificial intelligence creating Jira tickets and updating ERP simultaneously. That is the typical example that we'll have here. Okay, so the next slide is on autonomy spectrum. Okay, and what you are seeing here is a spectrum chart, human in, autonomous. Okay, so what this does is that you have human in loop, you have human on loop, and fully auto. So basically, human in loop requires approval before execution. Okay, so human will have to approve it each step. Okay, that is high control. They will have high control, but then low speed, and this is best for sensitive domains. Okay, then human on loop supervises but does not intervene constantly. So human monitors and overrides a balance of speed, yeah, and control, but most common in enterprise. Okay, and organization, of course, fully auto. Agents here, of course, acts autonomously, that's independently. And here you have higher speed, you have scale that requires strong governance, very strong governance. That is what this actually, will require. So organizations, of course, must choose autonomy level based on risk tolerance, okay? Typical example I will give here is artificial intelligence and financial advisor requiring approval versus autonomous trading bot or trading bots, whatever. So that is example I will give here. So we are going into the next slide, and this is the next slide is framework, the how-to, framework how-to, okay, the how-to. Okay, so now you have, well, I would say this is logos of LangChain, LangGraph, AutoGen, and you have Crew AI, and you also have semantic kernel. Okay, so this is basically the icon. It is a popular agentic AI framework, basically. Okay, so what this does is that the LangChain would, of course, let's think of this LangChain. What is it all about? Okay, I would say it is like a toolkit, okay, for building AI-powered applications, okay? Now, so it will help build agents pipeline, okay? And LangGraph here will support complex stateful workflow. Then AutoGen, of course, would enable multi-agent collaboration, okay? Crew AI simplifies team-based AI, artificial intelligence. The Microsoft semantic kernel, what it does is that it will integrate artificial intelligence into enterprise applications, okay? So LangChain, agent pipelines, LangGraph, stateful workflows, auto agents, multiple agent collaboration, of course, Crew AI, of course, that is team-based AI crews. And last but not the least is the semantic kernel, that is the enterprise integration. And I would say the typical example is, would I say, LangChain pipeline for, say, customer support automation. That is a typical example I will give in this case. Okay, so moving on to the next slide is data integration and RAG. Data integration and RAG. So RAG, of course, is retrieval augmented generation. That is RAG. That's what RAG is. And here you have a user sending query, okay? A user will send query to and say, okay, vector database, this is what I need. And think of a vector database as a librarian, okay? When you go to a library, of course, you may not really, would I say, know the language that the librarians use. Your own is to say you need this. Now, for example here, vector database, you have Bincom, Chroma, you give to librarians and said, look, I need this. And the librarian will say, okay, it will bring different, it will bring like different names, but they have similar meaning. And that is what vector databases mean. So now a user will send a query. This query, it will give a specific information or facts that he needs to this person here. Now, this person will now send, based on this information that the user is sending to this vector database, the vector database will now take that information and then send to this person here called LLM, large language model, which is the agentic AI. Now, this agentic AI will now take this information, give response, grounded response. And that response, because it's working based on facts, not just on question and answers, right? Working based on, so because it's working based on facts, it will give accurate results, okay, accurate response. So, and by doing so, it will try to reduce hallucinations, okay? You know, sometimes this AI may give guessing work. But it is your responsibility to send the correct input or the correct query to these vector databases. And based on the fact, they will now use that fact and send to the agentic AI. And agentic AI will now, based on this, fact and information that it receives from these vector databases, will now use that to give response that is grounded to be accurate. In that case, the hallucination is being reduced. Okay, so RAGs, like I said before, will connect agents to trusted knowledge sources. Okay, now vector database like Bincom, like I said, and Chroma will store these embeddings. Okay, will store those informations. And what happens is that when this happens, it will now reduce hallucinations and improves accuracy. That's what it will do. The example I will give here is, let's say, artificial intelligent legal assistant retrieving case law from vector databases. Okay, it's just like you have a company and you have a new employee, for example, and you're asking a new employee to give you information or say the company policy. Now, the new employee will now give you that information based on maybe generic information, but that will not be specifically for your company. So for that employee to give you accurate information, you have to give the employee your own company handbook, and it will be based on that handbook that you've given to your employee. That is, the employee will be able to give you exact information that you're looking for. So that is what this RAG is actually doing. So that's just it there. So the next slide. Okay, so the next slide is API management and MCP. Okay, MCP is Model Context Protocol. So what you're seeing here on the screen basically is an API, okay, gateway illustration with secure logs, okay? So this is AI model, and what this does is that, okay, MCP basically will standardize how models is interacting with the tools, okay, the tools here. So that is what MCP will do, and it will ensure consistent API communication, okay, and proper API governance prevent